Hey, 7th graders, Mr. Eller, getting another one of our flip lessons today. We're going to be talking about geography of the Erie Canal. So we'd have this sheet cut out and put into our interactive notebook, and we'll have this on page. I think it's going to be on page 8 of our interactive notebook. We're going to have a few guide notes up here, and then we're going to talk about some of the geographical problems and some of the solutions that happen due to the Erie Canal. All right, but let's go ahead and get started. Let me minimize myself. There we go. And alright, so geography is the study of landforms, and more particularly the relationship between landforms and people. So what does that mean? Geographers, kind of like what we talked about history yesterday, historians don't really study the past, they study parts of the past. Geographers don't study the land, they study the parts of the land, and particularly how the land may impact people and the movement of people and things like that. So, for example, the Erie Canal, a geographical historian is going to look at, number one, how did the geography of New York kind of impact how the canal was built or where the canal was built? How did the canal then impact the geography of Newark to impact the people? So those kind of changes and things like that would be something a geographical historian will look at. For other aspects, they're going to look at how does where the people live kind of impact how they live. When we get to Native American units, how does living in a desert climate impact the culture of people, and how does living in a treeless grassland impact how Native Americans are living? So a geographical historian is going to look at how landforms, mountains, rivers, lakes, streams, all that stuff, are going to impact people and how they live. So some geographical buzzwords, right? Some of the big ones we're going to talk about, your landforms, mountains, valleys, rivers, lakes, things like that. Big one for us this year is going to be the Mississippi River, the Great Lakes, the Appalachian Mountains, the Pacific Ocean, the Atlantic Ocean. Those are all going to be geographical terms that we're going to discuss during this year. Obviously, geographers are going to look at a lot of maps, a lot of atlases to be able to kind of look and figure that stuff out as well. All right, so we talked a little bit about this, the geography of the canal. First of all, the canal is 363 miles long. When it was built, it was 40 feet wide and 4 feet deep. Now, notice what I said when it was built, because I know if you go by Port Gibson over near Newark, it's way wider than 40 feet. It looks like a major river over there. But if you come up to Pittsford, New York, there's some places of the canal it feels like you could almost jump across. That's because the canal was widened later on. Couple times in the 1850s and then again in the 1900s to be able to accommodate larger boat traffic in certain locations. But that was the original build. There was 830 locks, or 83 locks built due to a 568 feet elevation change. So basically, Buffalo's up here, Albany's down here. We needed a way, if we're going this way, to get boats down, but if we're going this way, to get boats up, and that's where a lock comes in. Another geographical issue for the canal was they had a specific route for it, and sometimes there was rivers or valleys in the way. So they had to build what was called an aqueduct, which basically brought the canal over top of those rivers, kind of like a bridge. We'll look at kind of a big example of that happened in Rochester, New York. But all of these things are things that the Erie Canal builders kind of had to figure out as they go. There was no plan for this. There was no real thought out process other than kind of making it happen as they went along. All right, so the first big problem is going to be the Cayuga Marsh. You probably know this as Montezuma. All right, so big thing, they're digging in a swamp. So what they had happen is they would dig a hole, they would turn around, they'd wait, it would fill up with water. So they had to come up with a system where they kind of drained a lot of the area, dug it, and then maybe had to drain the water out. So this is why we talked about the first 15 miles or so was very, very slow. Digging through this spot was very slow. In the summer, it was hot, it was humid. Disease was being spread due to mosquitoes. Malaria was an issue, and hundreds were dying during the building of the canal. So due to this geographic issue, what did they do? How did they solve it? Well, kind of ironically, They dug most of the swamp during the winter months. Yes, the ground was at times frozen, but that was easier to deal with than it was to deal with, the swampy water, the mosquitoes, and all that stuff. You still had issues of frostbite. You still were seeing hundreds of workers die during this process, but it was less than what was happening during the summer months, and it was actually a little bit quicker, and it was the solution that they could use at the time for the Cayuga Marsh. The Irondequoit Valley, and this is Irondequoit Creek. It's actually kind of not even really in Irondequoit. It's in Pittsford, New York. But over time, the creek had kind of created this valley that kind of went down like this. Well, where they wanted the canal to go was kind of right through it. So one thing they could do was build a lock system, but they would have to build like the biggest lock in the world that they've ever built during that time period, which was going to raise that ship up 150 feet. Typically, locks were going 10, 20, 30 feet at that time. Didn't seem feasible to do. So they didn't want to build one big, huge lock. We're going to talk about an issue with Lockport. The geography wasn't the same as this position to help that. So what did they do? They built what is called the Irondequoit Embankment. So one of the things they noticed is that valley, which is shaped like this, well, it's got two ridges, right? So if we can somehow connect those ridges with earthen mounds and just bring in a ton of dirt, and I do mean dirt by the tons, and kind of build that up, we can have the canal go across. And that's basically what they did. And so actually at the Irondequoit Creek in this location, so the canal kind of runs here, the Irondequoit Creek goes underneath it because they've built kind of, now it's kind of like almost a drainage system that the creek goes through in that location. But they built up the land kind of around it to solidify that valley to make the canal be able to go over top of it. Genesee River. Genesee River is one of I think 2 or 3, including the Nile River, that the river flows north. So that means the canal was going east and west. You were going to have an intersection between the canal and the Genesee River, which doesn't seem like a problem, right? It's water, just cross over. Well, the Genesee River is a very, very fast-flowing river. It is not a terribly navigable river, meaning you can't have a boat on it in all places because it's shallow. So during those floods, it would actually damage trade ships. You got to remember, on the canal, these boats are being pulled they're along the towpath. There's, a ton, 2,000 to 4,000 pounds of materials on each boat, and it's being pulled by one donkey. If that hits a strong current or one horse, there's no way that animal's going to be able to stop that. So they knew also the springtime, you're not going to be able to use the canal because it would be flooded. So they have to figure some way. They can't go around the Genesee River. It goes all the way to Lake Ontario, all the way to Pennsylvania. So they have to figure out what to do. So they go to a very, very ancient technology you may have talked about last year with the Romans, and they build an aqueduct, which is basically they build over the river. And they build the Rochester Aqueduct. So the Erie Canal in downtown Rochester, when I was there, it's not there anymore, but we'll see a picture of where it was, actually went over the Genesee River, kind of like a road, and today it is actually a road. So to deal with that issue, they built the Rochester Aqueduct. And here we can kind of, let me get out of the way. Here we can see the aqueduct, right? There's the Genesee River kind of down here below. Here's the canal going up. Now this one has a more rounded turn. They did have it as a 90-degree turn, which caused a lot of traffic issues in the early canal. But at this point they had changed it. You can tell by kind of some of the architecture. This is probably late 1800s, early 1900s. But you can see right here is the Genesee River. Here's the canal going over top of it, and they did that 18 times. It's just the Rochester Aqueduct was quite large compared to some of the others. Lockport. Lockport wasn't even there before the Erie Canal. It came a big hub once this system was built. The problem was in Buffalo is basically they were building on just sheer rock. They were building on a geological formation called the Niagara Escarpment. Which basically, they were digging solid rock. There was nothing they could really do. And this was a severe, severe elevation change. and there wasn't really anything they could do. There wasn't the ridges where we can build an embankment. We have to go up. And so the solution to this was, instead of building one big lock like they thought about doing in the Ironquois Valley, let's build 5 medium-sized locks and kind of have it be a staircase as they go up. A lock is a water elevator. So basically what they do, depending on which way you're going, is if you're going up, you go in, they fill the water up, that brings you up. If you're coming back down the other way, they bring you in, they drain the water, and they lower you down. Something they use to raise and lower boats on canal systems. It's been something that's been used for, since canals were invented. But the solution was actually pretty ingenious. Today, if you go to Lockport, you're not going to see 5 locks. You're going to see 3. But they're still operational, still in use. You can see the old locks. They did kind of preserve them, which is kind of cool. But here you get a view of what that lock system looked like. So as this boat is going up, it's going to fit into this lock. They'll raise the water up. See, they got those big doors that'll close behind it. They'll pump the water in. Using pumps during this time period, but they were kind of doing it by hand to begin. Then it would come up to this staircase, raise it up again, this staircase, raise it up again, this staircase, raise it up again, this staircase, and then now we're at the level of the canal. And then coming down the other side, they would go down the other way. Oop, where am I here? There we go. Alright, so that was our flip lesson on geography and kind of how geography impacted the building of the canal and caused some problems and some solutions to the builders. So we'll have this, hopefully you've got all your notes down, hopefully you got a 5 out of 5 on the video, and we'll get together for the 5 out of 5 in the Schoology quizzes. Alright, Allard out.